All right. Welcome, everyone. It's 11 a.m., and I know everybody is going to try to jump to another one right after. So hi, I'm Marshall. Today, we're going to talk about open source GenAI on OpenStack. So what does that mean? Well, that means we're going to be doing some demos with running LLMs, running some VLMs, and other type of solutions that you can publicly find on open source repositories. And in particular, I'll talk about the solution I built to do just that. Most of the models can be found on Hugging Face nowadays. I hope everybody make good use of that. And the presentation is basically a collaboration between myself and the IU. So in university, run the Jetstream cluster. Mike and Julian could not join us today, unfortunately, but they were kind enough to loan me some really nice hardware for some of the demo we're going to be doing. Just for your self-awareness, I timed myself multiple times, and because we wanted to do the demos as part of that session, the foundation let me have 2 sessions. Today, we're going to talk about LLMs. Tomorrow, we'll do a video generation, image generation, and I have a few linked and a repo that I'll make public tomorrow for everybody to be able to do it at home. The only reason I'm doing it tomorrow is that because I don't want you to get a head start and see what we're going to be doing tomorrow. That's the only thing, right? So let me give you a quick intro. Julian Pistorius is the co-founder of the Exosphere project. So for people who are using OpenStack on Jetstream, you're usually getting a VM that runs on Exosphere. It's a wonderful front end for OpenStack. Mike Lowe is the lead system programmer for Jetstream. Mike has been around the OpenStack community for many years. They're both a member of the Scientific SIG. If you're curious about the Scientific SIG, we are representing every war battles that you ever had trying to run OpenStack for scientific workloads. We have a lightning talk around 4 p.m. and we're going to have a session at 5 p.m. They are in the program. If you remember Stack HPC, winners of the Super User Award this year, Sig Tefler is the other one of the other co-chair for the Scientific SIG. Please come and see us. We'll be happy to have a great conversation. If you join our 5 p.m., we'll also be sharing the link for the Slack if you want to just join and have this type of conversation. As for me, hi, I'm Marshall. I am the Chief Technologist and the VP of AI and Data Science at a company called Infotrend in the US. If you can see on the slide, you're going to see my GitHub repo. That's where tomorrow that thing will be public. So every demo I'm doing today and tomorrow will be available for you to run on your own stack or on your own local GPU as long as you have Linux. And I try to make everything on 24 gig of VRAM just to try to make sure everybody will be able to have fun, right? So if you have a 3090, 4090, or if you have a 5090, you'll be able to run everything. If you have something bigger and faster, you'll be happier. If you don't have NVIDIA, an NVIDIA GPU, it might be a little bit more tricky because some of those workloads are not really designed to be run on CPU. So LLMs can run on ARM, can run on CPUs that are just slower. Stable diffusion, I wouldn't recommend anybody try to run that on anything but massively parallel hardware. That means usually CUDA cores because it's basically running the same code on all those cores. To talk about me very quickly, I'm a builder, right? So if you have to try to remember anything about Marshall, I build stuff. So I usually go from what's possible to what we can actually ship. What that means is that, remember that joke, but it works on my computer? Oh, come on, you're supposed to know the joke, right? It's, well, we're gonna ship your computer, right? So it's basically the idea is that it's very different to have a solution versus something that you can share with people. So here I'm going to try to explain to you how we build something that makes it possible for you to use whatever I'm going to be presenting today. I have a PhD in distributed computing, so I kind of know what I'm talking about most of the time, I hope. And I've been designing a lot of AI machine learning frameworks for people to be able to basically just do this type of work. The only thing I want you to understand is that I'm a builder, but that also means communities, right? So I have been working on standards for cloud federation. I have a NIST SP500. I worked 20 years at NIST. I have an IEEE standard where I was a co-chair and one of the co-authors. And like I said earlier, I'm the co-chair of the OpenStack Scientific Sea. And finally, I'm a builder, relationship. So if you're here and you want to have a conversation later, please find me. I'm hopefully super friendly, and we'll get something running. So since this is an LLM conversation, I was like, well, am I the right candidate to actually talk about LLMs, right? So what I did is I went to my LinkedIn profile, asked an agent to basically tell you a little bit about me. But like everyone, I got started doing LLMs by trying system prompts, right? Write as Shakespeare, write as Cyrano, or write as a T-Rex. So just for fun, here is one. Am I a good candidate to talk about LLM? According to Shakespeare, kinda. According to Cyrano de Bergerac, avec panache, il croise le fer, des idées claires, précis et charmeur, un orateur idéal pour dompter les LLM. So for people who are wondering, yes, I'm originally from here. All right, let's jump quickly about what is Jetstream. So Jetstream is an OpenStack cluster. So for people who do HPC, it's a slightly different solution, right? Most people, when you do HPC, you have a scheduler, you try to push hard, you can push resources, and you're hoping you're going to get scheduled at some point within the next decade. Well, with Jetstream, it's a different thing. What you're going to get is you're going to get an OpenStack VM, usually deployed using Exosphere, and you're going to be able to start to run your framework right out of the box, usually Ubuntu 24. That's what I was given. Jetstream is available on 5 locations. If you want more detail on Jetstream, please take a look at the links. In particular, the South California talk by Julian, which was this year, where we basically give you, there is a YouTube recording if you really want to understand what Jetstream 2 and Exosphere will give you. The instance that all of those demos was running on was a really nice hardware instance with, for our purpose, H100, right? An NVIDIA H100, that's an 80 gig GPU. You might hear me say, I wish I had one at home, right? Because 24 gig of VRAM is fantastic until you try to run something serious. Given the speed of some of those work, we want more. So I'm going to talk to you about a framework I built. Why? Because like I said earlier, I'm a builder, right? So what I care about is making sure I can deploy my workload in something that is a repeatable fashion. So with that, how do you do that? Well, for GenAI, that means you need PyTorch. There is no question. Transformers, diffusers, which are the primary library you're going to use when building this type of work, rely on PyTorch. So what I've been doing, and I've started that program in 2019, it was just named different at the time, is building a framework for you to actually build Docker images for machine learning and computer vision projects. They are designed to work on CUDA or on CPU, because when you run a data science framework, you might not always need CUDA, but a CPU would work. The idea is giving you a common base framework. It's going to include either TensorFlow or PyTorch, always OpenCV. We have a Jupyter Lab because it's a very common interface for people to develop. And finally, and I don't see my friend from Canonical, it's Ubuntu-based because it makes it easy for me to build the builder. And if you look at the project GitHub, you'll find that it's basically generate a Docker file. That Docker file makes it possible for you to build custom images. Those custom images allow you to deploy solutions. I have made it so that it runs as a non-root user, which for most users is a welcome thing because we don't want the user within the container to be different from the user outside of the container, especially because you don't want to pollute your container with files that could be stored elsewhere, i.e. large language models. All right, finally, it's also a great thing to get started. And I say that because I always use my own container, I mean, you know, for good reasons, as a from for other type of AI application. Because when I start from there, I can just build more and always have the same base image, which I've already have on my system to basically deploy everything. Every demo you're going to see this morning are running from the same container. We're just going to create different virtual environments. I always get asked, okay, that's cool, but what can you do with it? And I'm like, okay, cool. Well, this is the result of a collaboration I've had with, every year I invite students to do a machine learning internship. And every year I get great projects out of them. And they give us an opportunity to demonstrate the capability of the tool. So those are just a short list of what you can do with it. The one in green are the ones I'm going to be trying to demonstrate this morning for you. Although it's going to be quick. And they're often modified version of the framework of those demos, just simply so that they show something for the particular demo we're going to be running this morning. The GitHub repo is already accessible if you just want to see. There is over 20 examples there. What do you need to run this demo that we're going to be doing today? Docker. I mean, you know, I said it's a Docker container, so hopefully we have Docker. We're going to do Docker Compose because it's easy for us to basically deploy everything within one Compose stack. We're going to need Tailscale. So for people who are not familiar with Tailscale, Tailscale is basically an overlay VPN. Makes it possible to use a 100.IP, which is non-routable, to interconnect every system you have and expose ports only on the Tailscale network. Why is that cool? Because I deploy on Exosphere, but I don't have to expose any port because my port exposure goes through my interconnected VPN. We need NVIDIA GPU simply because we want to run some of those GenAI demo faster. You also need a PyTorch base framework. So I'm going to be using Core AI because I know it really well, right? I built it. How to get started? What you see here is just a quick thing from the Docker Compose where I wanted to highlight a couple of things. First, Tailscale. When you deploy with Tailscale, you go through your dashboard. You get your authorization key, you add it, and then you expose everything through the Tailscale network to access the content. The GitHub that I mentioned will be made public tomorrow, gives you a far better README than my presentation in how to actually do that. We're also going to install Ollama. So why? Because anything we do with LLMs requires something that can serve model. So we're going to use Ollama because it's very simple to actually serve a model. We're going to run two local models, Llama 3.1, 8 billion, and ChatGPT, so GPT OSS 20 billion. So like I said earlier, I tried to make it possible for us to run within 24 gig of VRAM. So 16 gig is what we need to run that. Finally, you're going to need a version of Core AI. So we have the CUDA PyTorch OpenCV CPO version. And the numbers you see there are simply we're going to use a CUDA 12.6.3, PyTorch 2.6, and OpenCV 4.11. OpenCV, the only thing that's really important is OpenCV because OpenCV PyPy are never compiled for GPU. So I actually compile OpenCV for GPU usage, which makes a huge difference when you start using the DNNs. All right, that's basically, like I said, I tried to connect to the internet, but the OpenInfra 25 doesn't carry over here. So I have the video recording for backup. Just, you know, being paranoid works in that case. But I'm going to skip that. That one is just starting the Docker Compose. So when you work with Ollama, Ollama is basically a software solution to enable you to serve local large language model. You have three ways of accessing the information. The first one is REST. You can do it via curl, right? They have a good open API framework. Documentation for it is directly on their GitHub. Second one is to use the OpenAI API. So OpenAI has a standard API that most LLM proxy will make available to you, and most of them are compatible with that. You just don't get access to all the features, like tool calling, when you use the OpenAI API. So, and the third method is basically where you would use Ollama's API, pardon me, and that one gives you access to all the features, including tool calling. And tool calling is how we're going to do agent. So one of the first demo we're going to be talking about, I'm going to skip the how you set up Ollama, because I just told you everything that was in that video. We're going to do a search agent. So what is a search agent? Well, a search agent is basically web search plus web fetch passed to an LLM. So what does that mean? You're going to ask a question. When you ask a question, you perform a web search, just like you would do from your classic web page, and you're going to get URLs returned. Then you're going to do a web fetch to get the content of those web search retrieved to become the context of your LLM. Now, context for LLM is basically previous conversation, right? It's the assistant call for people who have worked with those APIs before. And then what you're going to do is you're going to use the context, use the question to ask the LLM to generate results for you, okay? Trick is, web search is something where, well, you still need web, right? There's no way for me to do web search without access to the internet. So we're going to do it with Sonar, which is a Perplexity AI, one of Perplexity's AI model, which does the web search. And then we're also going to do it with Ollama web search. And the reason I say that is that that particular project was released in August 25 by one of my really talented students. And at the end of last month, at the end of September, Ollama released their web fetch and web search API. So I basically re-engineered that notebook to use those to show you the difference between what an agent framework would look like, which is usually a long set of features, and the direct tool calling feature, because we were basically emulating tool calling. All right, so like I said, it's a video, and I apologize for that. But the way it works is that when you work with that type of work, what you have is you have a Jupyter notebook. From the Jupyter notebook, we're going to create a virtual environment. So like I said, with Core AI, you can basically create any virtual environment and separate them for usage. So we're going to install the package that we need, which usually is just the diff from the base container. And I'm going to pause so I can, with a diff from the base container. So like I said, I give you PyTorch. I give you a ton of things already pre-installed. But if you want to do GenAI, you're going to install transformers. Okay, that's basically one of the requirements. We're also going to install OpenAI and Ollama so that you can have access to those. But I already give you, I think, 5 gig of pre-installed base PyPy packages so that you can just continue the journey, right? That's basically an accelerator. So with that, remember what I said earlier? We are designing an agent. So we are going to set up a few functions. We need a way to call the local LLM. We're going to do Q&A to the LLM. We need to do the web search, get the context, and synthesize the results. And I have modified the notebook so that we can see those things happening. So those are just all the functions I was telling you you need to actually make it. The code is publicly available already if you want to take a look at it. And then what we're going to do is we're going to ask a question about Open Infra, OpenStack, right? We're at an Open Infra conference, so it only makes sense that we're going to do that. So what we're doing here is that we are going to use the hybrid mode for the agent, which is we're going to use Sonar and Llama 31 to compose the thing. So we are first asking for question, and we are getting results from the web search. And then we have using the local model, okay, running on OpenStack, we are, at this point, synthesizing the answer into a result. All right, and that is basically, what you see here is basically resynthesized from the web fetch. All right, so I did that with Llama 3.1. I could show you how it works with GPT-OSS 20 billion. You know, depending on what you're trying to do, very often Llama 3.1 is good enough. But I'm going to skip in order to save a little bit of time. Here you can see NVI top running, because it's always good to see how much resources you're actually consuming when you run those type of workflows. You can see it's an H100. If I can put my cursor over there. That's the NVIDIA H100. We have 80 gig of VRAM, and the biggest model is only, both model in memory give us 25 gigs. So it's actually really, really a nice piece of hardware. So if I move forward, I'm going to show you how to do it with Llama. So remember all I told you, you saw all that's me scrolling down and all the agents set up and things like that. That actually is a lot of code. Because we can do tool calling now, that piece of code is now those like 20 lines that you can see below, where we are basically just saying, okay, we're going to be basically asking the web fetch a question. It's going to perform the tool calling, which is a feature of LLMs, where they basically do web search, then web fetch, to provide us the context. And with that, we have the same result done fairly simply. All right, next we're going to talk about RAGs. Now, for people who are not familiar with RAGs, that's retrieval augmented generation. Basically what that means is, remember I talked to you about context. Well, it's a different type of context. Instead of being web search context, it's actually context that comes from documents that you have locally on your system. PDF, docx, Excel, whatever you have. As long as your parser is able to work with that, you're able to retrieve it. For people who follow Mark on LinkedIn, you'll also see him post about docling. Well, good news is we're going to use docling. It's actually used by RAGBits, which is the framework we're going to use to do RAGs. In order to do RAGs, what you need is you need to ingest the documents, but in order to do that, you need to transform them from their source format into basically chunk of text. And that's what the RAGBits and the docling do for us. Then what you do is you store them in memory into a vector store, a vector database. We're going to use ChromaDB for that. And then that becomes a context, and you can do search. So same thing as before. We're going to be setting up the virtual end. We're setting up a ton of functions. We're going to use an embedding model. The embedding model is basically what's going to convert text into embedding, so content that can be stored into a vector search, a vector database. Usually there are 700 numbers, okay? And you get a bunch of them. So when we do that, we're going to be doing the search on 2 documents. So the first document is going to be an exosphere document. The second document is going to be the scientific OpenStack book we released a few years back. And with that, we're going to be basically performing the parsing of the document. So on the H100, it takes about 42 seconds for both documents, which is really nice. And then you can see here we get a ton of vectors, right? We said a ton of elements. We get 451 for the scientific document and 62 for the exosphere article. So book versus article, right? We get different size. Then what we're going to have to do is we're simply going to have to store them into memory. Oh yeah, if you have 24 gig of VRAM, you wanna remove that. And after that, we're going to ask a question. So I made the notebook so that you can actually see what the context extracted was. So here is the context about the question. And remember what I said about vector store? So all it does is that it's going to convert the information from question into a vector-rich feature, which in turn will make it possible for you to retrieve relevant context. And that's how a RAG works. You find in your document the best content to match your query. And that becomes the context. Same conversation I do have for web search. So with that, the LLM is going to run, and we get an answer. And this is the answer that we get by, This is the answer that we get by running that context against the LLM. All of that can be done on your own computer. For LLM, the good news is that you don't always need a CUDA device. It works better. But if you're patient, you can run it on CPU. For stable diffusion, and that's tomorrow's talk, I recommend a very different application. So we've talked about large language model, but there is a second class of large language model, which is a vision language model. They are the one where you take your phone, you take a picture, and you're like, hey, tell me what's in the document. That's a VLM. And the only difference between an LLM and a VLM is that basically they're able to extract context from image. So the way it works, and we're going to use Gemma. So it's a Google model that was released. It's also specifically instruction tuned. That makes it possible for us to ask questions and queries. And because it's multimodal, what we're going to do is we're going to do image understanding. With image understanding, we're going to ask a very specific question. Describe the image, what is the field of expertise needed, and explain the idea behind the meaning of the image. Now, that looks weird, but that is basically called an interpretive analysis prompt, and that makes it possible for us to get more relevant results. So same thing as in the past, we always start from the same, generate your virtual end. We're going to load the model. We're going to skip the LLM question. And we are going to do the VLM part. Because it's also a large language model, right? So you can run it either as a LLM or a VLM. So as a VLM, what I'm going to do is I'm going to give it an image. So the OpenStack architectural framework. All right, I'm going to be like, okay, tell me about it. So good news is that when you run that, the software is going to be able to extract, it takes a while, is going to be able to extract information. So it's going to generate information about what is in the image, Swift, Cinder, other type of document. And then, because it is an LLM, it also has it has information that are part of the model. It is able to extend the information that you're going to see based on that. All right, final demo. I said it was demo heavy, right? I wish I could do them live, but we would not be done. A final demo is Flux. So for people who, like me, love to do image gen, and that's basically my talk tomorrow, we're going to use Flux. FluxNL is basically something that uses diffusers and transformers, so the language part and the image generation part, stable diffusion, diffusers, in order to generate images for us. So same thing, the code is actually available on Hugging Face. Grab it, grab the model, generate images. So in this particular case, we are going to load the model, and we're going to generate 5 images. You're going to be able to read the prompt and see the result. So the first one is a Jetstream image. So I always like to thank the Jetstream team for giving me access to the hardware for running this. So this is an ocean reflection on a starry night with the word Jetstream in the sky with whales and dolphins in the ocean. Okay, so that's basically image generation, and it converts the text part, that's the clip part, it converts the text part into something that's understood by the model, and that's the image generation part. So I have 5 images to show you, and then I'm done. The next thing is we're going to run a different one. So I control the seed. The seed is what makes it possible for me to always get the same result, right? Same thing with a random number generator that is with seeds. Exosphere. Happy 15th birthday OpenStack, by the way. And like I said, I've been with the Scientific SIG for 10 years. Happy 10th anniversary to the Scientific SIG. And with that, thank you very much for your time. I'm exactly at time, it sounds like. That's why I asked to split the talk into 2 talks. And now.